This video will show you how to open up your Bagel B DNA sequence in Benchling and use a couple of the tools to design an oligonucleotide we will use to make a mutation in the Bagel B gene sequence. To begin, navigate to benchling.com and sign up for your free academic account using your Google account or email. Before we begin with Benchling, make sure that you have downloaded the Bagel B sequence file and saved it to your computer somewhere you can find it easily. Once Benchling opens up, click on the plus sign on the left panel and select DNA Sequence, Import DNA Sequence. Now click on Choose a File and select the sequence file you downloaded. Before we begin any analysis, we want to optimize our workspace to make it easier to do our work. Down here in the lower right-hand corner, we'll click on Split Workspace to get rid of this extra panel. And we'll also get rid of this panel taking up space on the left by clicking this X to close it. The default view shows the sites in the sequence where restriction enzymes, bacterial enzymes that cut DNA, will cut. We don't need that information for this project, so let's get rid of it. Click on the scissors icon on the right, and on the drop-down menu for Cut Sites Visible on the Map, select None. Click the scissors again to close the restriction enzyme window. That's better. Now we can really see the DNA sequence for the Bagel B gene that we will work with. Notice that it has two complementary strands. The top strand is the sense or coding strand, and the bottom strand is its complement, the antisense or non-coding strand. The first thing we're going to do is translate this sequence so we can see the amino acid sequence encoded by these nucleotides. Select the whole sequence by clicking at the beginning and dragging your cursor to highlight all of it, or by hitting Ctrl or Command A on your keyboard. Now right-click. Select Create Translation and choose Forward. This tells the program to translate the top strand from left to right to yield the corresponding amino acid sequence of the protein. The amino acid sequence now shows up as the one-letter code. Notice that each amino acid is encoded by 3 nucleotides, which are referred to as a codon. Notice also that between the nucleotide sequence and the amino acid sequence, the amino acid position is given by these numbers. If the amino acid position is not shown, click on the gear symbol up here in the upper right corner and select Amino Acid Indices. Now find the amino acid you propose to mutate by its position. So for example, let's say that in the previous lab I had decided to mutate amino acid number 7, which is an alanine, to glutamine. I would find that amino acid here. Next, you'll select a sequence of 33 nucleotides, 15 to the left of the mutation and 15 to the right of the mutation, which should correspond to 5 amino acids to the left and 5 to the right, with your amino acid target right in the middle. Right-click and select Copy Special, Reverse Complement. Click the sequence to copy it to the clipboard. The reverse complement is the bottom strand given right to left. By convention, DNA sequences are written left to right in the 5' to 3' direction, and this is how we will order our oligonucleotides. Since the top or sense strand of DNA is 5' to 3' from left to right, the bottom or antisense strand is 5' to 3' from right to left. So for the 33 nucleotide sequence I have selected in the figure, the reverse complement begins with G, CC, CC, etc. Record the reverse complement sequence of your oligo by pasting it into a text file using Notepad or a similar app. Review the genetic code table and choose the appropriate codon representing the mutant amino acid you want to substitute in the sequence. Change the reverse complement oligo sequence you saved to code for the complement of that codon in your oligo. For example, if I want to change amino acid number 7, alanine, to a glutamine, I know that glutamine could be encoded by 2 different sequences, GAA or GAG. I'll use GAA since that only requires me to change 1 nucleotide. The reverse complement of GAA is TTC. So in my oligonucleotide sequence I saved, the central TGC reverse complement is changed to TTC. And now I'll save this sequence with a new name so I don't mix it up with the original one, using correct naming. Mutated A7E Bagel B oligo. Remember that the first letter is the original amino acid residue at the given position, The number is the amino acid position in the protein, and the final letter is the new amino acid. Now what you want to do is verify your oligo design using the BagelB sequence in Benchling. Select the entire sequence, then make a copy of the BagelB sequence by clicking the Create icon at the top right of the window. Then, New DNA. Making sure that your translation and sequence indices or numbers get copied too by checking the Annotations, Translations, and Primers and Preserve Sequence Indices boxes. Hit Copy and save it to your folder. Once you've saved it, you need to rename the copy by clicking the Metadata tab up here at the top, then clicking in the Name window and then on the little Edit pencil. Name this copy using the correct naming conventions. For example, mutated A7E, BagelB. Click the check mark next to the Edit pencil to save your new name. Now change the DNA sequence in this copied file to create the mutated version of the BagelB protein you've just designed. Click and drag to select the nucleotides to be changed. In the case of my example, and probably yours, it's just one nucleotide. Then type the new sequence and hit Enter to replace the selected sequence with the new mutated sequence. Check the translation and make sure it results in the change you expect to see. As we can see at position number 7, what used to be an alanine, A, is now a glutamine, E, in the one-letter amino acid code. If everything looks good, you are ready to move on to optimize the codon for your mutation using the Oligo Search tool at the D2D Cure page. Navigate to the D2D Cure page linked in the handout. Type in the name of the enzyme variant you have created using the correct naming convention, for example A7E for the mutation I just designed. Click Search, and the website will provide a codon-optimized DNA 33-mer sequence to use as a primer for the mutagenesis. Copy and paste it to your notepad file and compare it to the sequence you designed. If it's the same, that means the codon you selected is already the preferred codon for that amino acid. If it's different, that means that there's another codon that the organism preferentially uses to encode that amino acid, and your mutant codon has been changed to reflect that. Consult the genetic code table to verify that the new codon still encodes the mutated amino acid you selected. You can copy and paste this optimized sequence to a new text file, naming it as the optimized oligo sequence. Now you're done. The final step is to save your oligo sequence to the class Google Sheet linked on Canvas.